All right, everyone. Welcome to our online lecture. Um, for this lecture, we're going to be going through our worksheet, and then we're going to do a little bit of board notes. And so today we're going to be covering cost curves, specifically per unit cost curves. So if you were absent Friday, which was a lot of you, you're in a little bit of trouble because you're behind. And this chapter gets difficult, so I can't say it enough. Get caught up on what we learned on Friday and pay attention and take good notes on what we're going to do on the video lectures for the next few days. This gets complicated real quick, and if you don't know the basics, you're going to be in trouble. So there's your disclaimer. If you do not have the worksheet, there's two options. Come over here to our homepage, go to online lectures. You'll see here's Wednesdays and here's Fridays. There's nothing in Friday. Today's Wednesday. There'll be the videos down here, of course, that you've clicked on. And then manufacturing simulation, you can click and download the worksheet. Or there's a pile of them outside my office. So if you're on campus, you can just swing by my office and pick one up. Okay. So let's go back to our worksheet. So here is the data that we used in class in this worksheet. Remember, it's like the average of all the classes that have ever done the tennis ball game. And this is what we came up with. You plotted these curves, so you should have something here. And we've made it all the way to the fixed cost, or to the costs of production. And so we remember what we're doing. Firms are maximizing profit. And so at some point, we're going to get to revenues. That's the next few chapters. Right now, we're focusing on costs, which is an important piece of the puzzle. Firms' profits is, after all, total revenue minus total cost. So we break costs into two separate components in the short run: fixed costs and variable costs. Fixed costs are not going to change no matter how many tennis balls we produced. So can you think of some examples of what might represent costs that don't change no matter what we produce? Hopefully what you're thinking of are items that are tied to this variable K, capital. So things like building rent. No matter how many items we process, we still pay rent for our building. Whether we produce 0 tennis balls or 1,000,000, the rent is going to be the same. It doesn't change. It's fixed. Now, what about variable costs? These change as production quantities change. So if I want to produce more stuff, I have to pay for more inputs to do it. And so these are going to be tied to that variable L in the model that we build in this class. So for example, you have to pay workers to be able to produce in the short run. The more you want to produce, the more workers you need to hire, so your costs go up. Those are variable costs. If we had raw materials in our production function, that would be the same. So if you think about a pizza place wanting to produce more pizzas, they can hire a bunch more workers, but at some point they're going to need more materials for pizzas as well. And so dough, sauce, those things cost money. And so the variable cost of production goes up as they produce more pizzas. So fixed costs don't change no matter how many units we produce. Variable costs change according to how many units we produce. So let's compute these based on our data. Down here, I've given you another table, and we're going to suppose that the packaging machine that we used, we rented for $20 a day. And the building that we were in, we rented for $30. Workers, each of you that worked in my factory, let's suppose I was paying you $15. Let's make that per day, so that we're all in the same terms here. So day, $15 per day. Using these figures, let's fill out the table below. So let's transcribe our output down here. At 2 workers, we produced 11. At 4 workers, we produced 19.8, etc. So we can fill this in. 2 workers, we produced 11. 4 workers, 19.8. 6 workers, 27.8. 8 workers, 31.2. And 10 workers, 29.2. All right, we're going to fill in the costs according to produce. Now look what's happening, right? To produce more stuff in general, we hire more workers. What does that do to our costs? Well, we don't produce anything. We don't hire any workers. But do we have any cost? Think about that. You don't produce anything at all. Are there still costs involved to production? In the short run, yes. Remember, we still have to pay the rent for our building and the rent for our machine, whether we use them at all. So the $20 and $30 here, $50, we pay for those items. But what about workers? Well, we didn't hire any. And in this simple model where there are only variable input, not going to cost us anything. So what are our total costs then? 50 plus 0, 50. Now we come down here and hire 2 workers and we get some output. We produced 11. Do our fixed costs change? No. Regardless of how much units we produce, how many units we produce, fixed costs stay exactly the same. You're going to find that for every one of these. No matter how much we produce, we're still paying $50 in rent for our machine and rent for our building. What is changing as we produce more is variable cost. So to produce 11 units, we hired 2 workers. They're $15 per day. And so how much did we spend? $30. Next work day, we hired 4 people, produced 19.8. 4 workers at $15 per piece, a piece, 60. Right? We can see that the rest of the table fills in as follows: 90, 20, 150. Making our total costs 80, 110, 140, 170, and 200. Where all we're doing is adding fixed cost to variable cost to get total cost. Okay, so there's a whole bunch of data according to our production. But again, it's hard to see what's optimal by just looking at a bunch of data, just like in Utility Max. Sometimes it's a lot easier when you look at some math or a graph. So what we're going to do to begin building our graphical model of a firm is plot these curves. So down here, number 7, I want you to plot fixed costs, variable costs, and total costs. Now note that the axis is not workers, it's output. So quantity corresponds to these costs. So for example, let's look at total cost here. When I produced 0 units, it cost $50. So we can come down here at 0 and go up to about 50 and put a dot in there. Whoops, I've got white. Let's do blue. Put a dot in there, right? When I produced 11 units, it cost $80 to do it. So come here to 11 and go up to 80, right? So do that for all of your points here. So pause the video, take a break, and do that for all your points and plot these 3 curves. All right, hopefully you got something that looks like this: total cost, variable cost, and fixed cost. And so what we're going to do here with these curves is, if you take a look at question 8, we want to think about why total cost is shaped that way and build some intuition as to why that is shaped the way it is. So total cost sort of growing slowly and then starts to go up really high. And actually, if you plotted the third point, you actually saw that it came up like this and then curves like backwards, right? You get like this backwards bend to it. And so why do total costs grow slowly, then explode, and even go backwards? Like, why does that happen? So take the shot at 8 and take a guess. When we come back and you watch the next video, we'll talk a little bit more about it.